Okay, this is the last new section of Chapter 9, so after this lesson you should know everything there is to know about surface area, lateral surface area and volume of prisms and pyramids and cylinders and cones and frustums of pyramids and frustums of cones. So all these different types of figures. Just a reminder that you are not required to memorize the formulas, you just need to know how to use them. And today we're going to deal with the frustum of a cone, which basically, if you take what we did yesterday, the cone, chop the top off, now you got the frustum of a cone. It has a top circle and a bottom circle that both have a radius. It's got a slant to it, slant height, and it's got a normal height. So those are the units that we need to figure out. So h is the altitude, which is the vertical, straight up and down height. Slant height is the distance from the top edge to the bottom edge. The top radius r sub 1, the bottom radius r sub 2. And as with cones, sometimes they give you radius, sometimes they give you diameter. You have to establish what they're giving you to figure out what you know. So, when they tell me to find the volume, lateral surface area, total surface area of the following frustum, the first thing I'm going to do is identify the value of those four numbers. So first off, I know that for a fact that if the radius is, or sorry, the diameter of that is 6 feet across, that means that the radius is 3 feet across. If the diameter of this is 15 feet across, the radius is 7.5 feet. So I can record that information over here. So I'm going to say r sub 1 equals 3 feet. R sub 2 is equal to 7.5 feet. I'm going to go decimals. This is 3 feet. It looks like 31. 3. I'm going to put ft for feet. All right. So the vertical height, straight up and down, of course, is 5 feet. And notice they don't tell us the slant height. But I need to establish what it is based on the Pythagorean theorem. And this one's a little bit trickier than the ones we did yesterday because the other ones we had a right triangle sitting there. Notice this is 5 feet here, right? If I come over this way, let me just do a little drawing here. So suppose I go straight across, that's 7.5, right? If I come straight down from here, like so, at a right angle, so right where the edge of this triangle is, or where this edge of the circle is, comes straight down, so it's like this. This is 3 feet across here, right, which matches this down here, which makes this bit here equal to 4.5 feet. This is 5 feet, and this, of course, is S that we don't know. So we need to construct a right triangle out of it, but again, we have to, it's not going to be this radius and that radius, but those radii come into play to figure out what this dimension is. So I really need to know what that piece is there, and it's just the entire radius, 7.5 minus that much to get that. And then so at this point now it's a right triangle. I know both legs, so hypotenuse squared equals leg 1 squared plus leg 2 squared. So S squared is going to equal 5 times 5, which is 25. 4.5 times 4.5, which is 20.25. We add those together, S squared is going to be 45.25. So S is going to be the square root of 45.25, which is square root 45.25, 6.73. Round to 3. Let's go a few more. Let's go 6.7268. I want answers rounded to 3 significant digits, which I'm going to go more digits than that in my approximation, so that my 3 significant digit rounding should be pretty accurate. So, again, if I'm asked to do anything about this, I'm asked to find everything, specifically volume, lateral surface area, total surface area. At some point, all these numbers are going to be necessary, so I went ahead and figured out what they all equal. All right? It's not necessarily required to do that every time. If all it asked me for was volume, there's no slant height in volume, I wouldn't even worry about what S equals, right? But the total surface area has S in it, the lateral surface area has S in it, so the fact they're asking me for those tells me S was important, so I had to go and find it. So once I have all that information figured out, now it's just a matter of applying the formulas for what it's asking for. So it says find the volume. My volume formula states that volume is equal to 1/3 pi h times r sub 1 squared plus r sub 2 squared plus r sub 1 times r sub 2. And sometimes students will see these subscriptive variables that are being raised to powers get a little bit, I guess, upset about it. But r sub 1 just means one radius, r sub 2 means the other radius, squared means we're going to square the values. So r sub 1 and r sub 2 are identified here. So if I substitute what I know into this formula, volume equals 1/3 pi times 5 times r sub 1, which is 3 squared, plus r sub 2, which is 7.5 squared, plus r sub 1 times r sub 2, which is 3 times 7.5. So again, I know the value of all those variables. I simply substitute what they are into the formula. For me, I'm going to evaluate everything in that parentheses first. So I'm going to get this, all this stuff here down to a single number. Okay, I can type that exactly as it is on my calculator. So I'm going to just grab a calculator here. I'm going to type in just what I see right there. I'm not going to evaluate all the rest of the stuff. So I'm going to type in 3 squared plus 7.5 squared plus 3 times 7.5. No parentheses, no, just what's inside the parentheses. Just type in what you see, hit equals, and it spits out an answer. So my volume formula gets simplified down to volume equals 1/3 pi times 5 times 87.75. That formula in particular, that gets a little unpleasant, so if we evaluate that down to a single number, now it's just like the cone formula was yesterday. And we have top, 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 bottom. So just multiply the top stuff, divide by the bottom. So we're going to get 1 times pi times 5 times 87.75 divided by 3. Always divide the last thing. So we get 459.4579256. 0.4579256. The unit of length here is feet, and we did volume, so that'd be cubic feet. The last thing to consider is the significant digits. We want 3 significant digits. This rounds to 459. The next number is a 4, right? So if I just round it to 3 digits, 459 obviously is what it rounds to. Since none of those digits is 0, they're all significant, so all is well with that. So 459 is the right answer, 459 cubic feet. Okay. If it happened to say 459.5, now all of a sudden it's 460, still 3 digits, but only 2 significant, you'd have to put a bar over that 0 to make that 3rd significant digit in that point. All right, so 459 cubic feet is the volume. Move on to lateral surface area. I'm going to go to a new page. All right. So volume is still here. Now lateral surface area. So lateral surface area. Formula is right here. It's pi s times r sub 1 plus r sub 2. And we're simply applying a formula here. S, r sub 1, and r sub 2 are all over here. So to find my lateral surface area, it's going to be pi times 6.7268 times 3 plus 7.5. 3 plus 7.5 is 10.5. Once again, I want to evaluate that, the parentheses object. I want single numbers here. Single number, single number, single number. So go ahead and add the 3 and 7.5 together. Then grab your calculator and just type it in. So pi times 6.7268 times 10.5 gets us lateral surface area of 221.895084. That's going to be square feet. And again, I want 3 significant digits. This number rounds to 222. All 3 numbers are significant, so there's no zeros. So that'd be the 3 significant digit answer for that one. Our final task is to find the total surface area. That was lateral surface area. So for total surface area, we're going to be using this formula. So S equals, so total surface area. What the heck? I'll just finish it up here. All right, so just a reminder, R sub 1 was equal to 3 feet. R sub 2 was equal to 7.5 feet. H is equal to 5 feet. And S was 6.7268?
Yes.
7268 feet. All right, that's what they had figured out already. So my total surface area is, by the formula, pi, TSA, pi times S, which is 6.7268, times R sub 1 plus R sub 2, that's 3 plus 7.5. Notice that's just your lateral surface area, right? And then it's going to be times pi times the top radius squared plus pi times the bottom radius squared. So if we just look at that formula specifically, this is the lateral surface area, the area of the sides. Pi times the top radius squared is just the area of the top circle. Pi times the bottom radius squared is the bottom circle area. So my total surface area here is going to be that 221.895084. This right here is exactly what it was before, so it's still 221.895084. And then pi r squared for the top, pi times 3 squared is just pi times 9, right? That's 28.27. 433388. And then we're adding pi times 7.5 squared. 7.5 squared is 56.25, so it's pi times 56.25. That comes out to 176.7145868. So I simply have to add those 3 numbers together to get that total surface area. So 221.8950894874 plus 28.27433388 plus 176.7145868 equals, it comes out to a total surface area equals 426.8480081. So the total surface area rounded to 3 significant digits. This number rounded 3 digits is 427, because that 8 makes the 6 go up 1, so 427. No zeros, so that is all significant, so that's 427 square feet.